Once again, good morning and welcome to our class. Today we'll be learning about joint variation. Now remember, last Tuesday, we have learned about direct variation. If one variable increases, the other variable also increases. Yesterday, we have learned about inverse variation. When one variable increases, the other variable decreases. And one variable decreases, the other increases. Today, we'll have the third type of variation, and it's about joint variation. Let's recite today's memory verse found in James 1 verse 17. It says, "Every good gift and every perfect gift is from above, coming down from the Father of lights, with whom there is no variation or shadow due to change." And our MVCA boosters, that's what I've reminded you to please answer your MVCA boosters to get extra points, is about success as a joint variation. Success has many contributing factors, and think of the factors that will give you success. Will it be attitude, intelligence, determination? It's up to you. Write your equation of joint variation for success and state it also in an English sentence. So for our MVCA boosters, we'll expect two. First is the English statement of your joint variation, and the second is the mathematical sentence of your joint variation. The English sentence is the usual sentence that we have. Once we say mathematical sentence, it means the formula or the equation of variation for success. At the end of today's class, we'll be able to illustrate situations involving joint variations, translate variation statements, and solve problems involving joint variations. Now, here's an example, the area of the rectangle. Now, can you remember what is the area of the rectangle? Anyone who can give the answer. How do you compute for the area of a triangle, of a rectangle?
Length times width.
Very good. Area is equal to length times width. Or for some, it's just base times height. This is the base and this is the height. Now, this is an example of a joint variation. Why? Remember, in direct variation, we only have one variable. For example, area depends on length, or area depends on width. But look at here. We are starting to have two variables. Therefore, this makes a difference for a joint variation. Or shall I say, a joint variation is a combination of two or more direct variations. Now, what is a joint variation? A variable varies jointly as two or more variables if it varies as a product of these variables. I told you a while ago that joint variation is a combination of two or more direct variations. For example, let me give you an example. We say y varies directly as x. How do you write it? Anyone? Y varies directly as x. How do you write the equation of variation? Feel free to unmute your microphones. Again, y varies directly as x. How do you write the equation of variation?
Y equals kxz.
Okay, again, y varies directly as x.
Y equals KZ.
Oh, here,
Okay,
Jared
KX,
gave the
KX.
correct answer. Okay, thank you, AP. Y is equal to KX. How about this? Y varies directly as Z. Y varies directly as Z. How will you write the equation of variation? Very good. Y is equal to KZ. Here. These are two direct variations. Let's join them. That's why they call it joint variation. Now, how will we say that? Y varies jointly. It means two or more direct variations as Z and X. So we write it as Y equals KZ, KXZ. Please don't forget to write your K. Remember, K is your non-zero constant of variation. Now let's have a drill. We'll translate the following statements into symbols. And remember, K will be our constant of variation. Now, I will assign. Ready? The first one, Ali. The second one, Faith. The third, Althea. Then we have Ryan. Then the last will be Lykin. Ready? Can we start with the first one? Ali, how will you translate P varies jointly as Q and R?
Is it P is equals to Q, K, Q, and R?
Very good. Next, Faith, the second one. The area of a parallelogram varies jointly as the base and altitude. Faith Ramos, yes.
A equals to KBH.
Very good, KBH. Very good, Faith. For online students, I'm really sorry, but you notice in your quiz after the altitude, there's a heart. Actually, that happens when I'll place parenthesis and H. The ending will be a heart. Now, how about Althea, the third one? The volume V of a cylinder varies jointly as its height and the square of the radius. Althea? Hello, Althea. Can you unmute?
Hello.
Yes, we can hear you now.
B equals
K, H, what's next?
R.
Square of the radius. Hello, Althea. How are you doing?
R.
R squared. Very good. Because it's the square of the radius. So R squared. Correct. Next, Ryan. The mass of a circular disc varies jointly as the square of its radius and its thickness h. Ryan?
Ma'am, M equals R squared, equals R squared H.
Oops, you missed something. Again, you check. You're missing one letter. Let K be the constant of variation.
Okay. K, ma'am.
Okay, very good. So mass is equal to, remember the K, the constant of variation, the square of the radius, that's R squared, and thickness H, we have H. The last one, Lykin. The lateral area, L, of a cylinder varies jointly with the height, H, and radius R of the cylinder. Go Lykin. There's Lykin now. Oops, Lykin is gone. How about Janine? Hello, Janine. Yes, Janine.
Ma'am.
Go. Yes. Can you answer the last one?
Yes, ma'am.
Okay. How will you translate it? L?
L equals K H R.
Oh, very good. So you see, it's an easy one. Thank you so much, Ali, Faith, Althea, Ryan, and Janine for the answers. So you see, it's just simple as writing indirect variation, but there are two or more variables. Now let's go to finding the constant of variation. The first one, we find the constant of variation and the equation of their variation given 24 varies jointly with 3 and 4. Now, may I ask, is here, may I ask Ahava, how will you write the equation first? 24, translate. 24 varies jointly with 3 and 4. Ahava? Where's Ahava? How about friends? Are you there, friends?
Ma'am.
Okay, how will you translate this? 24 varies jointly with 3 and 4.
24 equals K, quantity of 3, and quantity of 4.
Oh, very good. That's 24 equals K times 3 times 4. We will be finding the constant of variation. So we have 24 equals 3 times 4 is 12 times K, that's 12K. Divide both by 12. So we will have K equals 2. This is now our constant of variation. Now, how will we write our equation of variation? Suppose this is Y, this is X, this is Z. So we write it as Y equals 2X and Z. This is now our equation of variation. Let's go to the next one. 32 is jointly proportional to 1/2 and 1/4. Now, may I ask Vance? Vance, how will you translate this? 32 is jointly proportional to 1/2 and 1/4.
32 equals K 1/2 times 1/2 times 1/4.
Oh, very good, Vance. So this is how will you write it first. Then we solve for our K. We have 32. 1/2 times 1/4 is 1/8. K. How will we eliminate 1/8? We multiply all or both sides by 8, the reciprocal of 1/8. So we have 8 times 32, that is 256 equals K. Then we write our equation of variation. Suppose this is Y, X, and Z. So we write it as Y equals 256 X, Z. Any questions? Or give me a thumbs up if
How
it's
did
okay. Yes.
how did there become an 8-man chart?
Oh, because remember, how will you eliminate 1/8? You need to multiply it by its reciprocal. And the reciprocal of 1/8 is 8/1 or 8. So you multiply all by
Okay.
8.
Okay, thank you.
Others? Or give me a thumbs up if you're ready to go to our problem solving. Very good. Now, let's go to our, yes, Prince.
Paan ma'am ba diri sa kaning statement og sa symbol lagi ma'am nakoy pangutana nano v equals khr squared nano na siya squared.
Here, because volume of a radius varies jointly as the height, so h, and square of the radius. That's why there is the r squared, because of the word square.
Okay ma'am, thank you.
Okay, you're welcome. Now let's go to our problem. The lateral area, say L, of a cylinder varies jointly with the height and the radius of the cylinder. If a cylinder with a radius of 3 cm and a height of 5 cm has a lateral area of 30 pi cm squared, what is the lateral area of a cylinder when its radius is 2 cm and its height is 8 cm? Now, can I ask Jared? Jared, how will you translate the first sentence into a mathematical sentence?
Is it R? Oh wait, hold on. 3 equals
The
K.
first sentence. The lateral area of a cylinder varies jointly with the height and the radius.
What do I do? What do I have to do, ma'am?
You need to translate the first sentence into a mathematical statement.
L equals K. L equals KH.
One variable is missing.
KHR.
Oh, very good. That's it, Jared. Lateral area, L, equals KHR. So the first thing to do is to translate the general statement. Next, we'll identify the given. It says if the radius is 3 cm and the height is 5 cm, the lateral area is 30 pi cm squared. Now, what are we going to do next? We need to solve for K. And to do that, we need to substitute R, H, and L. So we say 3, what's our L? 30 pi cm squared. You can have that. Or you can have 30 pi. Pi is a number, okay? Sorry. Equals K times H, 5 times our R, 3. So 15 times 5 times 3 is 15 K, 30 pi. Divide both by 15. K is equal to 30 divided by 15 is 2. And we're left with pi. So the value of our K is 2 pi. Now what's next? In the next part, we need to solve for the real problem. We are looking for the lateral area when the radius is 2 and the height is 8 cm. So here's for the real problem. In the problem, remember our R is 2 cm. Our height is 8 cm. And our K is 2 pi. So let's solve for the lateral area. L equals KHR. K is 2 pi. H is 8 cm. And R is 2 cm. Here, how to answer this with a pi? You need to multiply all numerical coefficients. So 2 times 8, 16, times 2, 32. Then the surname is pi. So 32 pi. cm times cm is cm squared. So our lateral area is 32 pi cm squared. Any questions?
Ma'am,
Yes, free. Ali, yes, Ali.
what
Ali or
if our y is a fraction or like a decimal?
If
Do we
P,
do the same way?
yes.
Okay.
Like for example, if in the problem it's a decimal, then your answer can be a decimal. If the given is a fraction, then you can have two options. You can write your answer in a fraction, or you can write your answer in the decimal. If it's a non-terminating, like it never ends, a decimal never ends, I suggest we round off properly to 2 decimal places. But here's a trivia. If you are vying for a mathematics competition, a decimal is not considered as the final answer. The best way to answer is using a fraction, because the fraction's answer is exact and it's not rounded off. Now, let's...
Thank you.
Okay, you're welcome. Other questions? No questions? Let's go to the next one. Here's our last problem. The area of a trapezoid varies jointly as the height h and the sum of the bases b1 and b sub 2. Find the equation of joint variation if a equals 40 meters squared, h equals 4 meters, base 1 is 8 meters, and base sub 2 is 12 meters. Now, we need to translate first the first sentence. So the area of the trapezoid varies jointly. Do not forget our best friend K, our constant of variation, as the height, h, and the sum. It means you will add. What will we add? And the sum of bases 1 plus base 2. Okay, now, let me first check. 1/2. That should be divided by 2. I'm sorry. There should be, in the problem, there must be an over 2. I missed that because that's the formula of a trapezoid. Now, let's find first for the value of K. Give me a moment for a while. Now, we state it as it is, okay? This one. Let's solve first for our K. Remember, our A is 40 meters squared. Our H is 4 meters. Our base 1 is 8 meters. And our base 2 is 12 meters. So let's solve for K. That's 40 meters squared equals K. What's our H? 4 meters times 8 meters plus 12 meters. So we have 40 meters squared. We have 4 meters. 8 plus 12 is 20 meters. 4 times 20 is 80. Meters times meters is meters squared. K equals 40 meters squared. Divide both by 80 meters squared. Cancel. You have K equals, cancel, 40 divided by 80. That is 1/2. So our K is 1/2. Now, how do we write our equation of joint variation? We have A, what's our K? 1/2 H B sub 1 plus B sub 2. If you notice, this is the formula for the area of a trapezoid. Now, any questions?